So these are all the jobs which I have submitted over the course of my journey here at Qubrid. But clicking any one job gives you a lot more granular detail about what was the device on which this job was executed, when did it execute, did it complete correctly or not, what were the number of shots which I used in this job, what was the cost of the job, and how many qubits did I use on this job, right? So these are basically some helpful details to allow you to gauge what did your program actually, return, or what kind of a system did you execute your program on, right? So these are two basic things that you need to before you start using Qubrid, the devices and the quantum jobs. I will pause for questions here if we have some, and then I will move on to the next segment, which is our Qubrid lab. Okay. Um, I don't think I see any questions right now. Prithvi, do you see?
No, no. I think they'll have questions in the Kubernetes lab part probably. Yeah.
Okay, perfect. No worries. All right. So let's move on to the next segment, which is the Qgrid Lab. So you see this tile here, right? When I click on it and click on next, we have this interface where you can select the instance which you want to run. So I have already pre-selected an instance, which is called a standard instance, and ran it. And once I launch lab, it will take me here. So this is the Qgrid Lab interface. This is a very familiar interface which you just saw in the previous demo. But the major difference is that this is now hosted on cloud, and it is also tuned for quantum. So this is your file system, which is coming here, right? And this is the code editor, which is the Jupyter Notebook. But not only that, you also have the extensions which you saw on the main tab. That is the quantum jobs. All your quantum jobs are here in this consolidated environment. You can see this, right? Besides that, you can see this, right? Besides that, you also have quantum devices. So you can directly see which devices are available right here in your Jupyter lab. And this is essentially just validating the fact that this is built for quantum, right? Other than that, we also have an environment manager. So for those of you who are familiar with Python environments, right, it is kind of like a very big hassle whenever you're trying to build different number of environments, or whenever you're trying to code and you have some environments kept in some particular folder. So we did not want our users to do that, right? So what we did is create an environment manager which persists your Python environment across your sessions, right? So for example, right now I'm using the kubelet environment, okay? And this is the kubelet kernel. So this is basically just telling you that, hey, I am in this particular notebook. I want to use this particular environment, and I have activated that kernel. And that is why I see kubelet imported correctly, okay? So this is, again, an overview of this lab platform. And for the demo purposes, I will basically just execute like simple jobs containing bell states, and then tell you how you could interface with real devices which are available through Qubit. So let's right. And there are a couple of things which you need to be aware of. So there are two concepts called the Qubit provider and the Qubit device. Okay. So Qubit provider is the abstraction which we use to associate all devices together which are available on the Qubit platform, right? So I basically do Qubit runtime import provider, and then I instantiate that provider. And when I call provider.get devices, it will get me a list of devices which are available through Qubit and accessible to you, right? Now I will choose the state vector simulator, the AWS SE1 simulator. I will see, okay, what's the target specification for this device, meaning that what kind of a circuit can be run on this device, right? Um, for this demo, I will basically build the simple Bell state circuit, which is a 2-qubit maximally entangled circuit, and then I will submit this circuit over to the AWS simulator. Now, a thing to note here is that AWS Simulator expects the circuit to be in bracket, but what we're going to be doing is we will be coding in Circ or in Qiskit and still submitting to the AWS device. So why is that important? Because you will not have to worry about whether you are coding in Qiskit, whether you're coding in Penny or any other quantum software package. We will take care of that conversion inside our Kubernetes SDK backend and allow you to submit those jobs, right? So building upon now coding in Circ, which is the Google's package, building that circuit and running it on the AWS simulator, right? And similarly, I will also build the circuit in Qiskit and execute it on the AWS SV1 simulator. See that the jobs are queued here, which are just coming through the kubelet provider. You can also see the quantum assembly equivalent of the job, and you see that the counts are also present. So that means that the job has executed correctly. Similarly, for the second one, it'll take a little while to execute, but it's fine. Now, note that straight vector simulator is not an ideal simulator. It's a noisy simulator, and you don't get ideal results, as was highlighted by our previous presenter as well. So the Bell state ideally should return 50-50 probability across all the shots which you used, but apparently it did not. It had like 502 or 498 shots for the measurement counts. There will be a similar case for Qiskit as well, but let's see whether the jobs gets through or not. Okay, so it's queued and it should be executed. Yep, so it's completed. Yeah, similar is the case for Qiskit, right? The thing which I want to again highlight is that we did not code in Bracket, neither we coded in Chasm, which is accepted by the device. We coded in Qiskit or Circ and then enabled those programs to be submitted on a Bracket device or an AWS device, which does not directly accept those formats. So this is kind of like the beauty of Kubernetes SDK. Now, we will also be running on actual devices. This is called the Rigetti Anka 3 device. And
Harshit,
yep.
sorry to interrupt. There is a question.
Hmm. Sure.
Just saw a question. Oh, somebody messaged me. Okay. So basically, we saw some instances failed, right? So they want
Yeah.
to know what is the reason behind it.
Yeah, definitely. That's a very good question. So there are multiple reasons for the failure of a job. So there are some instances when, let's say, this particular failed job, right? There are instances when the device is under maintenance, right? And whenever you're submitting a job to a device which is under maintenance, that will result in a failure, right? Because the device will not accept jobs. That is one of the reasons. Another reason could be the fact that, hey, you submitted a particular job which did not have the correct format which the device, even though it goes through the Kubernetes SDK, but it has some gates which Kubernetes SDK could not handle. And that was the reason of the failure of the job. So you need to convert those gates to the native set of the Rigetti device, right? And there may be multiple reasons of the job failure, but those are like some of the most common reasons which I've seen at least, right? I hope that answers your question.
Any follow-up questions, you can surely text.
Yep. Okay. Next, I will execute this metadata. So what I'm doing is basically getting the device ID of Rigetti device, right? And then getting the metadata of the device. After that, I am get the number of shots and then run the device. Okay. So note that whenever you're running a circuit on an actual device, that has a very high cost, not a very high cost, but it does have some extra cost associated with that experiment, right? So I did run this job a while ago, and then these were the measurement counts, and the cost was somewhere around 50 or 100 credits. I don't remember, but I don't want to spend those credits again on my account, right? So this is what you will see whenever you submit a job to an actual device. That it's a very similar format. You just select the device, you run your circuit, and you get the number of shots selected there, right? Once you've done that, you see okay whether the job is initializing, what's the status of the job, what is the result, and then what are the measurement counts of your job, right? This is basically just visualizing those measurement counts. And one thing which I'd like real devices are still very noisy, right? And the majority counts, even though they are falling under the 00 and 11 tab, but there are some counts under the 0110 buckets as well. And again, that is because of the noise, right? So since this is a real quantum device, we are bound to get some noisy results, and that is why we have some more, noise present from different of the qubits as well. So this is about interacting with real devices, right? Okay, I think I got some questions. All right, so basically, I'll end in a bit and then I will open the floor for questions. But I would say the main takeaways from this demo would be how you can instantiate a qubit device, what kind of a software package you want to choose to build your circuits, and how can you get a real device which is available over qubit and submit jobs to it. So these are like three main takeaways which I will recommend all of you to take from this demo, right? With that, I will, I think, open the floor to questions and patient audience, guys. Thank you. Okay, so I got a question from Vignan University, and they're saying if I will take a wrong circuit and processor, then will the jobs fail or not? Can you elaborate on that? I'm not able to understand the question. I will take a wrong circuit and processor. Other than that, okay, so Kiran is asking how many credits are required to execute a QML circuit because we cannot estimate the credits which are generally required in other clouds. And our systems on simulator take 7+ hours to train around 1000 data points. That's a great question. Um, the thing which I will first ask is that what is the qubit count of the circuit which you're trying to train? That's the first thing, right? The second thing is what is the iterations or what are the number of iterations you are calling for that training for the training of the ansats in that QML circuit, right? So depending on those iterations, you can estimate 10 qubits and 50 epochs. Okay. Um, I would recommend, um, given in each particular epoch, you are, let's say, executing for 1000 shots, right? So depending on that, you will be able to, estimate how many jobs you're running and also what is the number of shots that you're running for, right? So using that, you can estimate your credits. All right. Some other questions. So we have
Um,
Tejas from QSec.
yeah,
Can we
sorry,
use
Harshit.
platform? Yeah, go on, Prithvi.
Yeah, so in the final hackathon, I think you'll get close to 1500 credits for each team. So I think, Harshit, I think that is good enough to do um, the iterations that you're planning to do on your particular project. So
1500, yeah, I think 1500, we can get started with 1500, but
yeah,
depending on the use case, we can, choose required. Yeah,
yeah,
1500 should be very good to get started, at least. Yeah. And then we
some
have another question with from Tejas.
some participants have raised hands, but I'm unable to find out who they are.
Oh, okay. Message us, that would be great. So I'm taking a question from, um, yeah, the raised hands participants are not coming to the top. I just see that there are participants. Okay, no worries. I
Yeah,
will take the question from Tejas now. Can we use distribute credits over our website users and submit jobs with requests? Okay. Uh, yes, definitely you can use our platform to distribute credits over users. So I did not show that particular feature, but it is present in organizations that you could ask us to create an organization for you, onboard your users to this, right? I could choose to distribute credit like this, transfer credits. So whenever you have a user, you can choose to transfer credits, either deduct or add credits. Okay, so I hope that answers your question, Tejas. Then we have a question from uh, Thanekula Institute of Engineering. For our projects, are we going to have that much credit? Again, Thanekula, 1,500 credits initially because of the usage limits. So first we will give out 1,500 to get you all started. First showing that their solutions are actually working correctly with the simulators and a small problem size. Once that is done, then we will provide more credit. So the answer would be not initially, but definitely if you show promise. Okay, we have a question from Harsha. Is the platform for coding on quantum computing? Yes, definitely. There's a platform to code any quantum software which you like. All right. And we have temporal. Okay. Yeah, so this is basically, yeah, this is kind of like an old feature that we have, and it is not used a lot right now. But how you could do that is basically, take a circuit and then construct gates and then see the results directly in the cloud itself. So, for example, you have this, remove it or potentially create any measurements or some kind of a, T gates or probe the measurements and so on and so forth. So this is a very, I think, good to play around, but not a very, I would say, useful tool for scaling up your system, something like that. Okay. Then we have a question from Sahitya. So they ask what is meant by run shots, and that's a very good question, Sahitya. The so any quantum program that you execute, right? Uh, how you could get useful results out of that program is by measuring the qubit state. Okay, that is the any quantum program or a quantum circuit is probabilistic. Every single measurement will result in a particular outcome with some probability. Okay, so this is the context behind that shorts concept, right? Now, if you want to see where a particular quantum program is probability your system is going towards, you need a lot of experiments to get that probability. Okay, so that is what we mean by run short. So, for example, if you have, let's say you're tossing a coin, right? We all know that the probability of heads and tails is going to 50-50. But how do we know that? We do that experiment thousands of times, and on average, that goes on to 50-50, and that is why we say it is 50-50, right? Similar is the case for quantum systems as well. But we need to run the experiment multiple times or in multiple shots so that we can get that probability. Okay, what will happen to the credits when the quantum job is failed? That's a very good question again. If your quantum job is failed, you will be refunded your credits back. To show our final outputs on the QLab notebooks. Yes, definitely you'll need to show your final outputs on the notebooks.
I have a question here, Harshit, from
Yeah.
the Nuclear Institute. So, if we are aware of how many shots and tasks we have for our projects, are we going to have that many credits during finals? More or less, I
Yeah,
think.
I think I did answer that question, right? Again, if you require, definitely give it out on an as is basis, but first we'll need to see your initial solutions. So yeah. Okay, let me answer some more questions. So we have a question from Reddy Uday. Okay, so they're asking about when they will be getting the QRate credits. So Prithvi, do we have like a particular date for our agreement where we could, transfer credits to the students and which particular teams require those credits? Because some
Yeah,
teams, I think Reddy is asking that when these credits are going to be distributed.
yeah. So we are working that out with AppShare, and once and
Yeah.
teams are shared,
Hmm.
maybe 2 3 days beforehand we can do it, right? And on the day as well they can, because I don't want to give way quite early, because I don't want them to exhaust everything, and on the day of the hackathon they won't
Hmm.
have anything to work. to start with. So I'll
Makes
work out
sense.
with Akshay and share the details shortly with the respective teams. I mean, Akshay will share the details, of course.
Okay, makes sense. Then we have like how much time do we have for questions, Prithvi?
Yeah, I think we have, sir. Anil sir, can we continue for five more minutes?
Yeah, you can continue. Immediately after that, Chairman sir will also join. Meanwhile,
Sure.
I request, am I audible? After your session, Madam Gopika Shagandi Madam will greet the students. She is from Q Labs and they are prize money sponsors. Okay, you can take 5 minutes.
Yeah,
Okay,
we'll
sure.
take
Thank
three,
you.
four
Yeah.
questions, sir. Yeah.
Yeah, so I have four more questions. So one is from Gayatri Vidya Prasad College. Um, can you explain how to maintain feasibility and reduce error rate for IBM hardware for backends? Again, good question. So the first thing would be to use the Qiskits transpiler. So they have a very robust and a scalable transpiler, which basically takes your circuit, transforms it according to the backend which you're trying to use, but also has a lot of optimizations which are present in Qiskit's backend. So I would recommend using transpiler optimization level 3 and also figuring out what kind of a layout you want for your qubits to be present on the device. Choose, the best graph on your device on which you want to execute a circuit on. The second thing would be, I think, try to see if you can utilize some kind of error mitigation techniques. And there's a repository called Mitic, MITIQ. So I will write that down, MITIQ, Mitic for error mitigation and transfer of the definition. Yeah, so these two should be, good for getting started with your, reducing error rate for using IBM hardware. Then we have another question. Yes. So one person is asking, do we have to choose a hardware based on which type of gate, which type of modality we are using, gate-based or analog? Yes, you have to use that. And for now, we only have one particular hardware available for AHS, that is analog Hamiltonian simulation, which is the QRS device, the neutral atom device. Other than that, all the hardware which is available on QGrid is definitely gate-based. So, okay, I'll take a couple more questions. So ready.
To clarify, guys, I think not all the teams would require the Qubit platform. So we will share that list as well. For example, I think the job detection or from the job queuing system, probably that wouldn't require a quantum platform or a quantum credits to run it. So based on the requirement, Anil sir will share the details with you. Thank you.
Okay. Lokesh.
Unmuted.
Lokesh is asking,
Uh,
is it okay?
is
I'll
it
just take
all?
one last question. Yeah, I think just I'll take just one last question and then we should be okay. Uh, yeah, I'm pretty sure. I think we did answer this question about the release date for the credit points. They're going to be released like a couple of days before the finals, and I think you should be getting those credits in your accounts then. So yeah. Okay, I think I'll stop for questions now. And thanks a lot, guys, for joining in, giving your time, and looking forward to what you guys are building. Thanks a lot.